Hello, this is Mrs. Ward, and I'm going to go over the 2.1 to 2.3 review worksheet for our chapter test that's going to cover finding derivatives by using the rules and up into the last rule, which was the quotient rule and the product rule. So the number one says use the definition of a derivative to calculate the derivative of f. So this is when we're going back to the limits as x or delta x approaches 0, and that's that f of x plus delta x minus f of x all over delta x. So now I'm just going to substitute in the x plus delta x. So I am going to take the limit as delta x approaches 0 of 3, and then this will be x plus delta x squared minus 4 times x plus delta x plus 7 minus f of x. So putting this in parentheses, this will be 3x squared minus 4x plus 7. And I'm going to put this all over delta x. Remember, you must write the limit as delta x approaches 0 up until the last step when you actually substitute in delta x, or 0 for delta x. So I am going to square this and distribute the 3 at the same time. So I'm going to have 3x squared plus 6x delta x plus 3 delta x squared minus 4x minus 4 delta x plus 7, and then minus 3x squared plus 4x minus 7 when I distribute that negative sign all over delta x. Then if I did it right, everything that does not have a delta x will simplify. And I'm going to be able to factor out a delta x with what is left. So I'm going to factor out the delta x, and I will have 6x plus 3 delta x minus 4. And this is all over delta x. Now I can show that the delta x's simplify, still taking the limit as delta x approaches 0. And I will have 6x plus 3 times 0 minus 4. So my final answer, which is my derivative, is going to be 6x minus 4. Once I substitute that delta x in for 0, I no longer have to write the limit. That was part A. Part B says find the equation of the tangent line of the graph of point f at the point x is equal to 1. So I'm going back up to my original equation, and I'm going to find f of 1. So I'm going to say 3 times 1 squared minus 4 times 1 plus 7, because it's 3x squared minus 4x plus 7. And when I do that, I'm going to have 3, 10, and that'll be 6, I believe. So my ordered pair is going to be 1, 6, and I just found that my slope is this equation. So now I'm going to find my slope to find the derivative at 1. So 6 times 1 minus 4. And so my slope is going to be 2. So I am going to do y minus 6 is equal to 2. My slope times x minus 1. And when I do all that, I get 2x plus 4. And that is the equation of my tangent line. Okay, the next one, let f of x equal x to the fourth minus 2x squared plus 1. Calculate the derivative and use the result to determine the x-coordinates where f has a horizontal tangent line. So the first thing I'm going to do is find the derivative. Using the power rule, I'm going to take 4 times x, decrease that power by 1, minus 2 times 2, which is 4x, and then the derivative of that 1, which is a constant, will be 0. Now it wants me to find the x-coordinates where f has a horizontal tangent line. In other words, I want the slope to be equal to 0. So I'm going to set this equal to 0. And I am probably going to factor out a 4x and make this x squared minus 1. Yeah. And then I am going to have, say, 0, 4x, and then make this x plus 1, x minus 1. So x is going to equal 0, negative 1, and 1. And that's all it wants is the x values. It does not want the point. But be careful. If it wants the point, make sure you go and substitute the 0, 1, and negative 1 back into the original equation to find the point if it asks you to find the point. The next one says find dy dx, which means the derivative when y is equal to the square root of x times cosine of x. So I'm going to rewrite this as x to the 1/2 times the cosine of x. So I have to use the product rule for this. So when I use the product rule, I am going to leave x to the 1/2 alone, take the derivative of cosine of x, which is negative sine of x, plus not taking the derivative of 1/2 x, or x to the 1/2, that's going to be 1/2 x to the negative 1/2, and I'm leaving the cosine of x alone. So when I rewrite this, I am going to have the square root of x, well, that's negative times the sine of x, plus, and then this will be cosine of x over 2 times the square root of x. And I wrote the square root of x, you could have done x to the 1/2 power. So that's how you do that one. The next one, it says given the values, and it gives you that piecewise function. It says show that f of x is or is not continuous at 1. So another way I could ask this is find out when it would be differentiable, when it's continuous, however. So I want to see what happens at 1. So I am going to put 1 into this top equation, do 1 squared plus 2. And when I do that, I get 3. When I put 1 into this part down here, I'm going to have 1 plus 2, which is also 3. Since these are the same, it is a continuous function. If it's a continuous function, that means I can find the derivative and everything's happy and great. If these threes were different, then it would be a non-continuous function. It would be a non-removable discontinuity, which means I could not find the derivative. Number 5, find the derivative. So again, I'm going to have to use the product rule because I'm multiplying. Now, actually, I am going to use the product rule. I think I'm going to use the product rule. But if I didn't want to use the product rule, then I could FOIL those two out and then just take the derivative using the power rule. But I did the product rule, so I'm going to leave that 3x squared minus 5 alone. Taking the derivative of 2x minus 1, that's just going to be 2. Plus now taking the derivative of 3x squared minus 5, and that's going to be 6x. And leaving that 2x minus 1 alone. Now I'm going to clean it up a little bit. So I'm going to have 6x squared minus 10 plus 12x squared minus 6x. And putting in descending order of exponents, I am going to have 18x squared minus 6x minus 10. And that is going to be my derivative. If you would have multiplied, you would have gotten the same answer. Number 6, I have 1 plus sine of x over 1 minus sine of x. Since I have a term, 2 terms over 2 terms, I have to use the quotient rule. So I am going to leave the denominator alone. Take the derivative of the numerator. Well, the derivative of 1 is 0. The derivative of sine of x will be cosine of x. Minus, now I'm going to leave the numerator alone and take the derivative of the denominator, which will be this negative 1 times sine of x, so negative cosine of x. And this is all over my denominator squared. So when I clean this up a little bit, I'm going to have cosine of x minus cosine x sine x. Then this negative times this negative will make it a positive, so then I'm going to have plus cosine x plus cosine x sine x, and this is all over 1 minus sine x squared. The cosine x and negative cosine x, those two will simplify, and I have 1, 2 of these, so I'm going to say 2 times the cosine of x over 1 minus the sine of x squared, and that is my derivative. Finding the derivative again, I am going to use the product rule. So I'm going to leave the x to the third minus 2x squared alone, taking the derivative of 3 cosine x. Well, that will be a negative 3 sine x, plus taking the derivative of this is going to be 3x squared minus 4x, and then leave the other one alone. Now when I simplify that, I'm going to distribute that negative 3 sine x. I'm going to have negative 3x to the third sine x plus 6x squared sine x plus 9x squared cosine x minus 12x cosine x. And I'm looking at that to see if there's anything that has a like term, and there is nothing that has a like term, so I am just going to leave it like that. Number 8, I am probably going to simplify that before I do the derivative instead of doing the quotient rule. So I'm going to think of this as x squared over x plus 2x over x minus 1 over x. So I am going to rewrite this as x plus 2 minus x to negative 1. Now when I find the derivative, it'll be 1. The derivative of 2 will be 0. And then negative 1 times negative will be a positive 1. And then x decrease that power by 1. So I'm going to end up with my derivative being 1 plus 1 over x squared. And I left it like that. I think that's fine if I leave it like that. Number 9, I am going to find an equation of the line tangent to the graph of that when x is equal to 1. So the first thing I want to do is I want to find the point. So I'm going to find g of 1. So I'm going to do 1 plus 5 over 1 squared plus 2. So this will be 6 over 3 and 2. So the ordered pair that I'm looking at is 1, 2. Equation of the tangent line, so I want to find the derivative. To find the derivative, I'm going to use the quotient rule, so I'm leaving my denominator alone, taking the derivative of my numerator, which will just be 1, minus, leave my numerator alone, take the derivative of my denominator, which will be 2x, all over my denominator squared. And so then when I look at this, I am going to have x squared plus 2 minus 2x squared minus 10x all over x squared plus 2 squared. You really don't have to, but I'm going to combine my like terms. So this will be negative x squared minus 10x plus 2 over x squared plus 2. And remember, I'm trying to find the equation of my tangent line at the point 1. So I'm going to find my slope of my line at 1, my tangent line. So I'm going to substitute in 1 here. So I'm going to have negative 1 squared minus 10 times 1 plus 2 all over 1 squared plus 2 squared. And when I do that, I'm going to get negative 11. So I think that's going to be negative 9 over 3, 9. And I'm going to get negative 1. So my slope is going to be negative 1. So I'm going to do y minus, I believe it was 2. Yes, y minus 2 is equal to my slope, and then x minus 1. And my final equation is negative x plus 3. And that's the equation of my tangent line. Number 10, it says at what values of x in the interval 1, 4 is the slope of the line tangent to the graph of f of x squared is equal to the slope of the line joining those 2 points. So I'm going to find f of 1. So that'll be 2 times 1 squared plus 2, and that'll end up being 4. So I have 1 point that's 1, 4. Then I'm going to find f of 4. So there'll be 2 times 4 squared plus 2. So there'll be 32, 34. So I have a point 234. So the slope that's joining these 2 points, I'm going to do the difference of my y's over the difference of my x. And I'm going to get 30 over 1, over 3. Oopsie, this should be a 4. My bad, because I'm doing, yeah. Yep. This is 434. And so this will be 4 minus 1, and that'll be 3. So I have a slope, like the slope of the secant line that's joining these 2 points is 10. Okay, so we're good with that. Now I want to find the slope of the tangent line. So I'm going to find the derivative of that. So 2 times, so that'll be 4x, and then the derivative of 2 is 0. So I want this slope, I want to find the x value when this slope is equal to that 10. So I'm going to say 4x is equal to 10. Divide both sides by 4, and I get 2.5. So when x is equal to 2.5, when x is equal to 2.5, the slope of the tangent line is going to be 10, which is the same as the slope of the secant line that is joining those 2 points. Okay, number 11, find the derivative when you have that. So I am going to use the product rule. So I'm going to leave that 2x squared. You know what? Before I start though, my bad, before I start, let me rewrite it because I don't like having that radical. I'm going to think of that as x to the 1/2 minus 5. Okay, that makes me feel so much better. So now I'm going to leave that 2x squared alone, taking the derivative of the second quantity. That's going to be 1/2 x to negative 1/2. Derivative of 5 is 0. Then plus, I am going to take the derivative of the 2x squared, which will be 4x, and then leave the other one alone, x to the 1/2 minus 5. Then I am going to distribute. So when I multiply exponents, I add. So 2 times 1/2 will be 1. So 2 plus negative 1/2 will be 3/2. Plus, and then 4x to 3/2 minus 20x. So when I combine like terms, I'm going to have 5x to 3/2 minus 20x. And then for fun, I factored out a 5x because that's the lowest common factor. And then when I factor out this x, this will be x to 1/2 minus 4. So I left it like that. If you leave it here, I guess that's okay as well. Number 12, find the derivative when f of x is equal to that. Remember, you still have to do the product rule. So I am going to leave the x to the third minus 2x squared alone, taking the derivative of cosine, which is negative sine x, and then plus the derivative of x to the third is 3x squared minus 4x. Leave the cosine alone. Now distribute these. And I'm going to have negative sine, whoopsie, I'm going to write the x third first. So I'm going to have negative x to the third sine x plus 2x squared sine x plus 3x squared cosine x minus 4x cosine x. And I don't think there's any like terms, and there's nothing else I can do with that. Number 13, find the derivative when you have that. 13 is asking me to find the derivative, so I'm just going to go ahead and do that. I am going to use the power rule, so I'm going to take 2/3 times 9, then reduce that power by 1, so 2/3 minus 1 will be a negative 1/3, plus, and then I'm going to have that 1/3 times 2, reduce that power by 1, which will be a negative 2/3. I'm going to multiply before I do anything else, so this will end up being 6x to the negative 1/3 plus 2/3 x to the negative 2/3. Okay, the lowest common denominator I'm going to have is a third, so I'm going to factor that out. And the lowest exponent I have is negative 2/3, so I'm going to factor that out. What I have left is what do I have to multiply 1/3 by to get 6, and that would be 18. What do I have to add to negative 2/3 to get a negative 1/3, and that will be 1/3. And then plus 2 is what I had to multiply 1/3 by to get 2/3, and then I factored out the negative 2/3. So rewriting it, taking care of that negative exponent, I'm going to have 18x to the 1/3 plus 2 over 3 times x to the 2/3. I could factor out a 2 in the numerator if it would help me out. It's not going to, but I will factor it out anyhow. And that would be my final answer. Either one of these is acceptable. All right, moving on to the next one. It's at 7, and that'll be 6 times 7 plus 1, which will be 43. There's no units in the problem, so I can't really come up with units for my answer. Number 15 is looking at a graph, and I want you to find the derivative of p, and they're telling you p is the product of f and g. So the way I think of this is to find p, that's a product, so I'm going to leave f of x alone, multiply that by the derivative of g of x, plus, take the derivative of f of x, and then leave g of x alone. So remember that the derivative is the slope, and f of x is just f of x. So when I go to do this f of x, so I'm looking at f, they want when x is equal to 5, so 1, 2, 3, 4, 5. So everything I'm looking at is going to happen at this line 5. 2, 3, 4, 5. So everything's happening at this line here. So when I do this, I want to find f of x. Well, f of x is going to be 1, 2, 3, 4, 5, 6. So f of x is 6. Then it wants me to multiply it by the slope of g of x. So here's g of x. I want the slope of this line. Well, I have this point here. I have this point here. I'm going up 1, 2. So my rise is 2. My run is 1, 2, 3, 4. So my run is 4. So 2/4 or 1/2. And then I want to multiply by the derivative of f of x. So that's the slope. There is no rise, so my slope is going to be 0. It doesn't even really matter what g of x is because I'm multiplying by 0, but g of x is 2. I might as well put it in there. And so when I do this, I'm going to have 6 times 1/2, which is 3, plus 0. So my final answer is going to be 3. The best thing you can do for yourself is write this down so you know what you're substituting in and you don't get all lost and confused and upset. Find the derivatives. So I am going to leave my denominator alone, take the derivative of my numerator. Well, the derivative of 16 is 0. The minus, leaving that 16 alone and taking the derivative of the denominator, which will be 2x, all over my denominator squared. So multiplying by 0, that's gone. So I'll have negative 32 over x squared plus 7 squared. And that is my final answer for my derivative. 17, this is asking us to use the alternate form of a derivative at 2. So I'm going to go ahead and do this. So once Okay, the next one's asking you to use the alternate form of a derivative to find the derivative at 2. So I'm just going to go ahead and do that. So I'm going to do f of x, which is 3x to the third minus 4x, and then minus f of 2. So finding f of 2, I'm going to do 3 times 2 to the third minus 4 times 2. So that's going to be 824 minus 8, and I get 16. I do. Minus 16 all over x minus 2, and I'm taking the limit as x approaches 2. So when I look at the numerator, I don't know how to factor it. Well, I can't really factor it because it's raised to the third power. So, but I know x minus 2 has to go in there because that's the way it works. So I didn't know how to do it, so then I thought, well, I'll do synthetic division, and this is where you get really mad at me because you're thinking, oh crap, I don't remember how to do that. But we'll do it. We'll work through it. So here's something raised to the third power. Nothing is squared. Something raised to the first, and then I have my constant. Remember synthetic division? I bring down the 3. I take 2 times 3, and I get 6, and then I add them. So 0 plus 6 is 6. 2 times 6 is 12. Add them, and I get 8. 2 times 8 is 16. Add them, and I get 0. And I'm really glad I got that 0 because I needed to get that 0. So when I rewrite this, I'm going to write the limit as x approaches 2. So one of my factors is the x minus 2 because this 2 ended up with a 0, so I know it's a factor. And then I'm left with, remember, this started with x to the third, so this is x squared. So this is 3x squared plus 6x plus 8 all over x minus 2. Now the x minus 2's will simplify, and I'm left with a limit as x approaches 2 of 3, and then in place of the x, I'm going to write 2. 2 squared plus 6 times 2 plus 8. So that'll be 4, 9. And when I do all this, I get 32. And you know what? I just want to check it because I wasn't sure. So if I go up here and I find the derivative, and this is me just doing extra work and checking it. So if I go up here and I do the derivative, that's going to be 9x squared minus 4. And the derivative at 2 is going to be 9 times 2 squared minus 4. So that'll be 36. So I do get 32, so it does check. So that is using the alternate form of a derivative to find the derivative of x is equal to 2. Number 18, find the derivative when you have that. So I'm going to rewrite it first to make this x to the 1/2 plus x to the 4/5. So when I find the derivative, I'm going to have 1/2 x to the negative 1/2 plus 4/5 x to the negative 1/5. And then I wonder, I wrote it as 1 over 2x to the 1/2 plus 4 over 5x to the 1/5. And I left it like that. I'm going to be perfectly honest, I left it like that. Okay, number 19, if I'm given trig function and I'm giving something where it's multiplying, I am 100% every single time going to simplify that before I do it because I really don't want to do the product rule with trig if I don't have to. So when I think of this, tangent is the sine of x over the cosine of x, and cosecant is 1 over the sine of x. So the sine of x will simplify, so f of x is equal to 1 over cosine of x, which is equal to secant of x. Now to find the derivative, I'm just going to find the derivative of secant of x, which is going to be secant of x times tangent of x, and I'm done. Much, much easier, and on the online when I printed out the answers, I did the other way if I did the product rule, and you will find that this is much easier to simplify your trig before you actually do the derivative. Number 20, this is asking me to find the second derivative, so I'm going to first find the first derivative, and I guess I should use the same notation that they're using. So I'm going to find dy dx, which would be the first derivative, so that's going to be 10x minus 3. That wasn't hard. Now to find the second derivative, whoopsie, wrote that wrong. I am going to take the derivative, I'm going to take the derivative of this and end up with 10. And that's it, I'm done. It's literally that simple until you get to the trig. So now I'm going to do the same thing. I'm going to find the first derivative. So the first derivative of cosecant is going to be a negative cosecant, negative cotangent. Whoopsie, cosecant comes first. Doesn't really matter, but now to find the second derivative, I'm going to have to find the derivative of this, which means I'm going to have to use the product rule, and I'm going to have to be very patient. So in order to do this, I am going to leave the cosecant alone, and I'm going to do the negative sign with the cosecant, so I'm leaving that alone. Taking the derivative of cotangent, which is going to be negative cosecant squared x, then plus taking the derivative of this negative cosecant, so that's going to be negative cosecant x cotangent x, and then taking the derivative, oh, and leaving the cotangent alone. Then I am going to clean this up a little bit. So when I do this, negative times a negative will be a positive. So this will be a positive cosecant cubed x plus, actually minus, cotangent squared x. Okay, when I went to take the derivative of this cosecant, there's a negative sign that I'm bringing along, and then the derivative of cosecant is negative. So I'm going to have that negative times a negative, so this will be a plus. I knew it was a plus, but... All right, so now I'm going to factor out a cosecant. So when I do that, just one cosecant, just one. That's all I can factor out. I'm going to have cosecant squared x plus cotangent squared x. And then I thought of this as 1 over sine of x. And I thought of this as 1 over sine squared x plus cosine squared x over sine squared x. So I don't know if there's an easier way to do this or somebody will tell me. So the 1 plus, this has a denominator sine squared x, and then the 1 plus cosine squared x. Oh, is just 1 plus cosine squared x. I almost fell into that trap. And then I'm going to have 1 plus cosine squared x over sine cubed x, and that is my derivative. It has to be 1 minus sine cosine squared to make sine squared. That's what I was trying to do, and I knew I was wrong. So I hope this helps, and I will see you next time in class.